Okay, so today we are looking at calculating gradients and also looking at the angles of inclination. So our learning intention is to gain the knowledge in calculating the gradient of a secant and using the knowledge of angles of inclination to calculate the gradients. So students can use the gradient formula, m equals y2 minus y1 over x2 minus x1, or use trigonometry to calculate the gradient. So let's do some examples. All right. So we know that the gradient is rise over run, and we can calculate that using the formula y2 minus y1 over x2 minus x1. Or otherwise, it's the change in the y values over the change in the x values. Okay, so here we have, imagine we have 2 points, 1, 2, so 1, 2, and 4, 6. Okay. So what we could do, I've seen it before, we could create a triangle. Alright. Use a triangle. And notice that this length here would be 6 take away 2. So this length here would be 4 units. And this length here would be 4 take away 1 would be 3 units. Okay. So using Pythagoras, we know that the length between A and B is 5. But what we want to do is find out the gradient. So the gradient, we can use the formula, the y2 minus y1 over x2 minus x1. Now it doesn't matter if you have A or B as your first point or the second point, as long as you're consistent. So let's say this is going to be, let's say 1, 2 is going to be your x1, y1, and 4, 6 is your x2, y2. Okay, so we're going to go 6 take away 2, the y values, over the x values, 4 take away 1. Okay, so 6 take away 2 is 4, 4 take away 1 is 3, so we have a rise of 1.5. Yeah, so for every 1 unit across, I go 1.5 units up. And just double check. 6 take away 2, 4 take away 1, yeah, 4/3. Yeah, so for every 1 unit across, I go up 1.5 units. Now, looking at this, if I use this as a triangle, I could actually calculate this angle here. Yeah, I could go tan theta is equal to the opposite over the adjacent side. So tan theta is 4 over 3. So theta is inverse tan 4 over 3. I plug that into the calculator, degrees, shift tan 4 over 3. I get an angle of 53 degrees and 8 minutes to the nearest minute. So if I was to continue this line, yeah, it says, this tells me I'm making a 53-degree angle with the x-axis. Okay. So that kind of takes me on to this continue on with this another example. So if I have 2 points 0, 0 and 4, 4, we know that this is 4 units and that's 4 units. Well, this angle here, right? So if I use tan theta equals opposite over adjacent, so tan theta will equal in this case 4 over 4, or tan theta equals 1. Well, inverse tan of 1 will equal 45 degrees. Yeah, so the gradient m, which equals the gradient, is equal to tan theta. Yep. So if I plug in tan 45, I will get 1. Alright, let's do some examples. Let's calculate the gradient between 2 points, 1, -4, and 5, 5. So if I draw a quick sketch, 1, -4 is down here, and 5, 5 is up there. So it looks like I'm going to get a positive gradient, positive numbers. Let's try using the formula. y2 minus y1, x2 minus x1. So I'm going to use this as my first point. So 5 minus 4, and 5 minus 1 gives me 9 over 4. So my gradient is 9 over 4, or 2 1/4. Okay. Let's calculate the gradient between these 2 points. So I'll do a quick sketch again. So I've got -2, 3 somewhere up here, and then I've got 4, -5. So I'm going to have a negative gradient. So using the same formula, m equals y2 minus y1 over x2 minus x1. So I'll use this just for the sake, actually, because I use that point first, I'll use this point first, just for the sake of 3, -2, minus, so we've got -5 and 4. So that's 3 plus 5, which is 8, minus 2 minus 4 is -6. So my gradient is -8 over 6, or -1 and 2 over 6, which is technically -1 and 1/3. Okay, that's how I calculate gradients between 2 points. Second quick example, what is the gradient if the line that makes a 60-degree angle with the x-axis? So what that means is I have this line and it's making 60 degrees there. Well, m is equal to tan theta. Now, in this situation, tan is 60. So using the calculator, I plug in tan 60. I make sure I'm in degrees mode. Yep. And I get 1.732. Now, if you know about exact triangles, you can write this, so I'll do a little note. So with exact triangles, we have this triangle where that's 60, this is 30, comes from an equilateral triangle that's cut in half. That's going to be 1, 2, √3. Well, tan of 60 is √3 over 1. So as an exact value, this is going to be √3. If that part doesn't make sense, don't stress out. It's just in case you know about exact triangles, you could write it as an exact value. Yeah. If you plugged in √3, you'd get the 1.732. Okay. So what is the gradient of the line that makes a 150 degrees angle? Okay. So if it's making a 150 degrees angle, it's somewhere around about here. So this is 150 degrees. So let's see what happens if we put in m equals tan theta. And if we put 150, what do we get? So tan 150, we get -0.577. And that kind of looks right because we have a negative line. So we have a negative angle. If I want it as an exact value, what I'm really looking for is I'm looking for this angle in this quadrant, which is technically 30 degrees because the whole thing makes 180. So tan, using this exact triangle, tan of 30 is 1 over root 3. So as an exact value, this is going to be negative 1 over root 3. And you can check that. So negative 1 over root 3 gives us the same number. Okay. So just be careful with your negative, with the negative quadrants. Most of the time it should work, but just be a little bit careful about that. Okay, so to be successful to calculate gradients, you need to know the formula, and you need to be able to use trigonometry to calculate the gradient. Okay, thank you.